In this tutorial, we are going to prove this theorem which says angles in the same segment of a circle are equal. Okay, let's first understand what a segment means. Any chord drawn on the circle divides it into two parts which are called segments. Now, if this chord does not pass through the center, then we will have a minor segment, which is the smaller one, and a major segment, which is the bigger one. Now we have to prove that angles in the same segment, like this black part, this upper part, if in this segment, if I take this arc PQ and I create an angle in the upper segment, like consider I take a point here and I join it with P and Q, or I take a point here and join it with P and Q, or I take this point or this one or this. I mean, whichever point I take, the angles formed will always be equal, and that's what we have to prove. The same thing is applicable for the smaller segment too. Suppose I consider a point on this side of PQ, then all angles made on this side will be equal to each other. Just like all angles made on this side are equal. Okay, one thing to note, that the angles made on this side will not be equal to the angles made on the other side. Only the angles made in the same segment will be equal. So let us consider these 2 points to prove this theorem. Now I will call this point as R and this point as S. What I have to prove is angle PRQ is congruent to or equal to angle PSQ, which means I have to prove this angle and this angle equal to each other. Now I will do one more thing. Join PO and join QO. Now angle POQ, this angle at the center, this angle is equal to 2 times the angle made on the circle, meaning 2 times the angle PRQ. Now you may be asking how this happened. To answer that question, we proved a theorem in the last tutorial which stated the angle subtended by an arc, like arc PQ, at the center is double the angle subtended by it at any point on the remaining part of the circle. So any arc will make an angle at the center which is double the angle it makes on the circle. I mean on the remaining part of the circle. If you want to see the proof of this theorem, then I have given the link in the top right corner of this video. Now let's call this equation as equation number 1. Now similarly, angle POQ is 2 times angle PSQ as well. Since this angle is also made by this arc itself, so this means the angle at the center will be 2 times angle S as well. In fact, I should make this center angle different from the other 2 angles since I have to prove these 2 to be equal. So this angle will be double of this angle, and the reason for that is the same as before, of which I have already given the link in the top right corner. Now I will call this equation as equation number 2. So from 1 and 2, these 2 are equal. So from 1 and 2, 2 times angle PRQ is equal to 2 times angle PSQ. This is also POQ and this is also POQ, which means these 2 are equal. 2 cancels out with 2 on the other side of the equation. This implies PRQ is equal to angle PSQ, meaning this angle and this angle are equal. So you can draw this angle anywhere on the circle. Your solution will always be the same. You just have to give a reference to the theorem we talked about earlier. If you are not aware about that theorem, then I strongly recommend that you go check that out. So that's it from this tutorial. Keep watching Mathemafia.